Welcome to the Power of Span. My name is László Deák. In this video, I will give you an introduction to spans, then I will give you a step-by-step guide to upgrade an existing application with the usage of spans. This application is called Holiday Span. The application itself counts the number of times of a given day of the week has been selected as a holiday. The input of the application is a holidays CSV file. Let me open the holidays CSV and show it. It contains the name of the person who takes the holiday, a start date and an end date. We can assume the file is correct and all the dates are valid. If we take a look at the file, it's over 14 megabytes. So the span can give us a huge benefit when we are processing this file. Let me show you the program itself. We will start off from a holiday processor classic class. We instantiate it, we create a stopwatch, we start the stopwatch, run the application, stop the stopwatch, and finally we print to the console how long it took to run the application itself. Let me show you the holiday processor classic class itself. It has an internal dictionary, which is a private, and contains how many times of a given day has been taken as a holiday. Its only public method is the run method. It processes the file and finally it prints the results. Processing the file means opening the file itself, creating a stream reader which reads through the file line by line, and we process each line. The process line splits the line by the comma, removes the empty entries, and with the returned string array, it indexes the last and the last before element of the array and parses them as dates. Finally, we just process the dates. Parsing the dates is relatively simple. We have a fixed format, so we can use datetime.parseExec. Processing the date itself is quite simple. We just iterate over the dates from the start date to the end date. We exclude the Saturdays and the Sundays. If the given day has not been added to the dictionary, we try to add it with a count of 1. If it has been added, then try add returns false, and we just increase the counter of the dictionary. Finally, if we take a look at print result, we iterate over the days dictionary, and for each entry we output a line to the console which contains the given name of the date and the number of times it's been called. If we run the application, we can see it runs under 2 seconds and it outputs the given days. Let me copy paste this holiday processor classic class and paste it to holiday processor incremental.cs. I will rename the name of the class as well, and I will make sure this name is going to be used in the program CS. Let's begin with an initial cleanup. First of all, we can tell that there are 5 days we are interested in. So let's set number of 5 for the capacity of the dictionary. In the constructor itself, we can add the 5 days from Monday to Friday, and we will add all days with the count of 0. So I will just copy and paste Monday and reset the key of the entry to Tuesday, Wednesday, Thursday, and Friday. If we know there are 5 entries and all entries are already added at the beginning of usage of this class, we can remove the try add method. So we only need to update the counter of the dictionary entry. And then for the print result itself, to be a little more efficient, I will use a string builder with a capacity of 128. 128 of capacity should be enough to contain the number of characters for each day of the week and then a count as well. In the for each loop, instead of printing to the console, I will use the string builder to append the entry, the key, and then a semicolon, the value of the entry, and then a new line character. Finally, I will still print to the console, and I will call console.writeLine with the string builder's toString. In this section of the video, I will read the file into a pipe. For this, I will use a new NuGet package. So go to the project, add a new NuGet package, which is system.io.pipelines. Select the package and click Install to install the latest stable version. Once installed, let me return to the code. I will declare a new method. This method will read the file itself. It will be an async task, and I will call it readFile. It will have one input argument, which is a pipe writer. For this, I will need to add the necessary usings. Let me call it writer. In the method body, I will just open the file. So in a new using, I use file.openRead to open the holidays CSV file. Inside the using, I will use a while loop. In the while loop itself, I will just iterate over the file and read it into the pipe. For this, I declare a memory, and I ask for a chunk of memory from the writer itself. The size of the memory will be configured later on. Once I have the memory, I can read the file into this memory. I declare an int count, which will store the number of bytes that have been read. And I will just call file.read and memory.span. A span will be a pointer to the internal underlying data structure of the memory. If 0 bytes have been read, then we can break the loop and exit. Otherwise, we just advance the pipe's internal position. Next, we will notify the pipe reader that there's some new data available in the pipe itself. For this, I will call writer.flashAsync, and as this is an async method, I will need to add an await. Finally, we can check if the pipe reader has completed. If it has completed, the result of the flash async will be completed and we'll break the loop. Once we break the loop, we just call writer.complete to notify the reader that we have completed. Next up, I will read the data from the pipe and just process it. So first of all, I will need to know what's a new line character. So I will declare a private read-only byte called new line byte. This byte will contain the UTF-8 representation of the new line character. So in the constructor, I give it a value. And to get the byte representation, I will get encoding the UTF-8.getBytes and just give it the environment at new line. Now let's go to the process file itself. So I will keep this method, but I will change the signature and the implementation of it. So instead of returning a void, it will return an async task. And it will need a pipe reader. I will call it reader. We will use the pipe reader to read data from the pipe itself. Again, in a while loop, I will read the data from the pipe. So for that, I just call reader.readAsync. The result is put into the read result. It contains two important things for us. One is the buffer, which is the data itself, and the other is a flag marking whether the operation was successful. To get the buffer itself, I declare a buffer, which is a read-only sequence of bytes. It means it can be one or multiple arrays of bytes, but at this point it doesn't really matter to us. We will deal with that later. I will also declare a sequence position, which is a nullable type, and I'll call it end-of-line position. It will contain the position for the end-of-line character. To get the current position, I will just get position, new line byte. If it returns null, it means there's no end-of-line position in the given buffer. Otherwise, it returns the sequence position. So it has a value. We can process the value up until the end-of-line character. So I call process line, and I will need to slice into the buffer from the beginning up until the end-of-line character. Process line method currently accepts a string, but I will give it a read-only span, so it will mark with red lines, but we'll correct it later on. Next up, I will move the window of the buffer. So we're not interested in the beginning of the buffer itself, so we can slice from the end-of-line character to the end. Finally, I need to find if there are further end-of-line characters in the given buffer. Note that a buffer might contain less than a single line, or it might contain multiple lines as well. So in this while loop, we just iterate over until we find end-of-line characters. Once we are completed, we can advance the cursor of the pipe itself. I will specify the buffer.start that we have consumed and the buffer.end that we have examined. We can check the read result itself. If it's completed, we will just break the loop. Once we have completed the loop and exited, we'll call reader.complete. In this section of the video, I will implement the process line method itself. First, let me declare a new private read-only byte. This will be the comma byte. The same way as we have for the new line byte, the comma byte will store the representation of the comma encoded in UTF-8. So I will just call getByte, pass a comma, and safely index into the first element of the returned array. Let's go to the process line method itself, remove the existing implementation, and change the signature as well. It will accept a read-only sequence of bytes. This read-only sequence may contain data segments. It may contain one or multiple data segments. If it's only a single data segment, I can process it with a span. So I will call process line, get the first data segment of the read-only sequence, and just get the span of it and call process line itself. Otherwise, I will need to copy the data segments into a single array, so I can pass it as a span to process line. For this, I will rent a buffer of bytes. I will ask the array pool to get me an array which is at least the size of the data itself. Once I have the array, I can copy the read-only sequence of bytes into this new array. This array is pooled, so it might be reused in multiple occasions. Once I have the data copied into the array, I will just call process line, but I can't process the whole array itself. I will need to pass a slice of it, so I call as span, and I will need from the beginning until the end of the data a slice of it. Finally, once the data has been processed, I will return the array to the array pool. Next up, we'll need to implement the process line, which accepts a read-only span. So I will just use the IntelliSense to get the method signature, and I will use the span and get the last comma of the data. The index of the last comma can be get by the last index method. I will just get the last index of the comma byte. Once I have the comma, I can parse the end date, which is from the comma until the end of the data itself. So I will call span.slice, and I want to slice from the last comma plus 1. Next, I will move the span, the window of the span, and I will drop the end of the parsed data. So I will slice from the beginning up until the comma. And I will repeat the same as I did for the end date, for the start date as well. I need to find the last comma of the remaining data. And once I have the position of the last comma, I will just process the start date and parse it as a date from the comma again to the end of the remaining of the span. When I have the start date and the end date as well, I can call process dates, and I will pass both start date and end date. In the next section, I will implement the parseDate method. I will go and refactor the existing one. First, it can't accept a string, but it will accept a read-only span of bytes as an input parameter. Secondly, it can't use datetime.parseExec because, strictly speaking, the underlying data is not a datetime but only a date. So to parse a date, I will use a new helper method. It will be called parseNumber. I will pass the read-only span to it and an out parameter, which will be the year. I will repeat this for the months and the days as well. The return value of the parse number will be the rest of the unparsed data part of the read-only span. Once I have the year, the months, and the day as integers, I can create and return a new datetime, which is a struct, so it does not reside in heap allocation, and just pass the year, the months, and the day to it. Let's now implement the parse number, and I will copy paste this implementation. The implementation itself will be really similar to the process line method. It will find the last position of the slash, and from that last position of the slash to the end of the data, I will use UTF-8 parser.tryparse to parse an integer number and return the rest of the unparsed data span. For this, I need to declare a new private read-only byte, which is the slash byte. It is similar to the comma byte and the new line byte. To get the representation of the slash, I will use the UTF-8 parser and getBytes method. Next up, we will need to implement the run method itself. The run method will declare a pipe, and I will pass some pipe options to the pipe. And these pipe options will have thresholds set to 4K, 2K, and 1K, which defines the internal behavior of the pipe and its cursor and internal data buffer. Once I have the pipe, I can open the file, so I will call the read file method and pass the pipes.writer to read file. The returned task I store in a local variable, but I don't await it. I will do the same for the processing. I will call it processing task and just call process file and pass the pipe.reader to it. Finally, I will need to await both tasks to complete, so I will call task.whenAll, passing both tasks to it. As this is an asynchronous method call, I will need to change the signature of the run method to async task. Let's go to the program SCS and await now the p.run. Next, let's measure the garbage collector's internal behavior in the classical solution. I will use perfview for the measurement, and I will open perfview and click collect and collect. I will give a name to the data file, which is the classical solution. I will make sure that sample alloc is checked and I start the collection. Let me run the holiday span application now. Once it's completed, I return to perfview and stop the data collection. Perfview needs a couple of seconds to process all the data logs. Once that's completed, I will navigate to GCStats under Memory Group tab. We'll need to look at the GCStats of the application, which is .NET Holiday Span.dll, and the table itself shows there were 23 garbage collections, all for generation 0, and the total allocated megabytes are over 150 megabytes. If we want to observe these garbage collections, let's open the events and filter down the process to the .NET. Let's search gc/triggered events. So these are the GC trigger events, and these are the 23 events we saw in the other table. Let's open any of the stacks. Once opened, I will navigate into the stack of the application. So here I need to drill down and open the holiday span DLL, and drill down until I see my application's code and stack. So under core CLR, I have holiday span.program, and if I drill into it, I see holiday span and holiday processor classic.processLine, which trigger the garbage collections. Next up, let's repeat the same steps for our refactored application. I will make sure the refactored application is compiled in release, open perfview, and open the collection window. I will make sure the data file is called perfview data incremental. Select .NET sample allocation and start the data collection. I run the application, and once it's completed, I return the purview and stop the data collection. When the data file is completed by the purview, I can open the trace file and navigate to the memory group and open GCstats. Let me search for .NET Holiday Span DLL again, and you can see there were 0 garbage collections. To double confirm this, we can also open the events. And in the events window, we will search for the .NET process and for the GC/triggered. We will double confirm there were no GC events triggered. So this confirms with the GCSS table. In this video, I have shown how to refactor an existing application with spans. I have measured in Purview how this improves the memory efficiency, and we have also seen that this improves the execution time as well. Thank you for watching.